This lesson, 12.3, trig identities and equations, is going to be much shorter than the previous section. I would like for you guys to start with a warm-up from algebra. Can you guys solve 2y squared minus y minus 1 equals 0? So pause this, solve it, and then resume the video once you think you've solved it. Okay, I hope you took some time to solve that. First, I'm going to factor. So I know to get 2y squared, 2y times y. To get a negative 1, I need a positive 1 and a negative 1. And so I'm going to do plus 1 minus 1. So that could be negative 2y plus y gives me the inside. So to solve, this is the zero product property. 2y plus 1 equals 0, or y minus 1 equals 0. Solving these, I've got two answers. Y equals negative 1/2 or y equals 1. That's what we're going to do today, but we're going to use trig identities or equations when we're solving. We might have to incorporate the unit circle as well. So for your first example, I want you guys to solve 2 cosine theta minus 1 equals 0. So to do this, we've got to solve. Nothing's being squared, so I don't need to factor it, so I'm going to solve by adding 1 and dividing by 2. What this is asking is, at what angle does cosine equal theta? You could also say this, theta equals cosine inverse of 1/2. What that's asking you for is, where on the unit circle is cosine 1/2? One thing I forgot to mention is these problems will always come with a stipulation. For example, this one says that theta is between 0 and 2 pi. Sometimes they'll say theta is between 0 and 4 pi. So this is super important. This is in just one full circle. If I look at the unit circle, where does cosine equal 1/2? Go find that and come back and report. Hopefully you looked and you found that happens at pi over 3. You could have said 60 degrees. And it also happens at 5 pi over 3. And so you could have said that that's 300 degrees. Either one is fine. I tend to use radians more than the other. There's your first example. We have one more example, and it's much more difficult. But that's it. Just 2 examples today, 1 homework problem. When I get back next time, I'll give you some more problems. Here is this example. Number 2, negative 2 cosine squared x, instead of theta, they're using x, minus sine of x plus 1 equals 0. You can use theta, you can use x, you can use any variable, as long as they're the same. Because I have cosine squared and sine, I know I'm going to have to do a substitution. You guys remember cosine squared theta plus sine squared theta equals 1. That's an infamous trig identity we need to memorize. You could change it to x, if that helps, since this problem is in terms of x, not theta. If I were to solve for cosine squared, I would just subtract sine squared to the other side. I'm going to take this and I'm going to sub it in. How are you supposed to know to do that? Well, the more problems you do, the better you get. So negative 2, I'm going to insert 1 minus sine squared x, and then I'm going to continue my equation. Distribute, add like terms. I could combine negative 2 plus 1. This looks weird, but because I have a quadratic in there, sine is being squared, and sine of x is not, I'm going to make another substitution. I'm going to let y equal sine of x. So then I have 2y squared minus y minus 1. And that should look like that very first warm-up problem that we did. You factored it. Hopefully you remember doing that. I'm going to take sine of x and I'm going to put it back in. This is just kind of weird. So I'm only giving you one really difficult problem here. When I return, we'll do some more. I'm going to put 2 sine of x plus 1, and then sine of x minus 1. Just like before, that zero product property, I'm going to let each one of these equal 0. Each expression is going to equal 0. This looks like example 1, where I individually solve them. So I'm going to subtract 1, divide by 2. So sine of x equals negative 1/2. And over here I'm just going to add 1 to the other side. So I'm looking for two different things. And at the very beginning I forgot to write down again, but they're saying this time x is between 0 and 4 pi. So that's 2 full circles on the unit circle, so 2 full rotations. X is going to be between here. I have to think of all the possible angles where sine is negative 1/2. So if you look at your unit circle, sine is negative 1/2 at 7 pi over 6, 11 pi over 6. That happens within one full circle. So if I go around again, it's going to happen again at 7 pi over 6 plus 2 pi, and 11 pi over 6 plus 2 pi. Those are the 4 answers for just where does sine of x equals negative 1/2. Then I also need to talk about where does sine of x equal 1 over here. That happens when x is equal to pi over 2. Or if I go around another full circle, pi over 2 plus 2 pi. So this plus 2 pi business is because I'm going around to another full circle. So I've got my 4 answers here for negative 1/2, and I've got my 2 answers here for 1. I just need to get a common denominator here. 2 pi is the same thing as 12 pi over 6. And 2 pi is the same thing as 4 pi over 2. I'm just getting a common denominator. So my answers are 7 pi over 6, 11 pi over 6, 19 pi over 6, 23 pi over 6. Those 4 for the 1/2. And then x equals pi over 2 and 5 pi over 2. I've got all of these answers. So technically there are 6 answers that solve this equation up here at the very beginning. Don't stress, we can work together when I get back.